Can a material change in a key piece be enough to ruin the World Cup dream of an entire team? What if that decision is accompanied by internal warnings, hidden flaws in tests, and a technical secret that the FIA has already discovered? Subscribe to continue uploading more of this type of content now, if we continue. Ferrari is not only a Formula One team, it is an institution, is living history of motorsports. And for this reason, every technical decision made in Maranello is loaded with symbolism that goes far beyond sports. By 2026, the entire SF26 project was conceived as the ultimate rebirth. The team had learned hard lessons in the previous years. Although the 2024 season showed green shoots and a performance that allowed them to get closer to McLaren and Red Bull, the internal structure knew that with the new 2026 technical regulations, they needed to take a bigger step than any other. It wasn't about evolving, it was about revolutionizing. Meanwhile, the atmosphere in Maranello became tense. The board, headed by Vasseur, clung to the official discourse: it is a calculated risk. But in the hallways, the conversations were different. Some simulations began to show unforeseen side effects, such as overheating of certain components of the MGUH system, pressure loss in the ERS, or even microcracks in critical areas of the steel block when certain engine maps were forced. The consistency required by the new regulations was far from being achieved. And in the midst of that storm came the most compromising revelation. One of the validation tests carried out by the FIA in Cologne reflected that the engine did not meet the stable minimum energy efficiency values required to homologate a complete power unit. This did not mean an immediate disqualification, but it did put all the work done by Ferrari under scrutiny. And at the same time, he gave his rivals arguments to press for more aggressive oversight of the project. What began as a technical leak ended up becoming an institutional crisis. Because when the FIA detects inconsistencies, the entire Formula One ecosystem reacts. Media pressure increased. The questions at press conferences became more awkward. Even some technical partners began to express concern. And most worrying of all, several key engineers in the engine department began to publicly doubt the direction taken. Not frontally, but with gestures, internal comments, and above all, requests for urgent review of multiple validation parameters. In short, Ferrari is not only facing a technical challenge. You face a scenario in which internal confidence is shaken, in which your own strategic decisions are under fire, and in which any miscalculation could mean wasting the first regulatory cycle from the beginning. An extremely delicate situation, in which each race will be a trial, each abandonment a sentence, and each leaked data one step closer to collapse. While many teams chose to refine what was known, Ferrari decided to reinvent what was fundamental. And in Formula One, that is not something that is done lightly. At the heart of the SF26 beats a mechanical concept that has unleashed a storm of technical debates and internal controversies: the use of steel cylinder heads in the heat engine. It may seem like a minimal detail, even irrelevant to someone who is not immersed in motorsport engineering, but this decision represents a total break with decades of technical evolution in the premier category of motorsport. For years, aluminum was the preferred material for F1 engine cylinder heads. Its lightness, ease of molding, and good thermal conductivity made it the standard choice. But for 2026, Ferrari wanted to go further. They decided to go with high-strength steel, a specialized alloy designed to operate under extreme temperatures and pressures without losing its structural integrity. The idea was simple on paper, but complex in execution. If the engine can withstand more heat, it can burn more mixture, increase combustion pressure, and therefore obtain more power, without fear of thermal deformation. This innovation is not a simple change of material. It is a complete redesign of the engine's thermal behavior. In the most optimistic simulations, Ferrari projected that this solution would allow unprecedented thermal performance to be achieved, forcing pressure zones in the combustion chamber that had never been possible with aluminum. And that leap opened new opportunities. If the motor is kept more thermally stable, the need for cooling can be drastically reduced. That means smaller radiators, a much more closed side pod design, and consequently cleaner aerodynamics. In Maranello lingo, they called it double gain: more power and less drag. That promise was enough to justify months of investment, simulations, and experimental testing. Internal reports were even leaked that spoke of up to 0.25 seconds per lap as a direct estimated gain. In Formula One, that is not an improvement. It's a revolution. It is the difference between being in the fight for victories or being left off the podium with no options. And that is why the steel bet was not simply technical, it was political. It was a declaration of war on the technical conservatism of the gridiron. However, this decision was not unanimous within the team. From the early design phases, some engineers raised questions. Steel, although stronger, is also denser, more difficult to work with, and much more expensive in terms of manufacturing and machining. Its greater thermal resistance does not easily compensate for the logistical complications it introduces. In addition, its ability to dissipate heat is not as good as that of aluminum, which requires much finer thermal management. In other words, it is a more robust material, but also more delicate to handle in the closed ecosystem of an F1 car. The most delicate thing about the matter is that, until now, no team in the recent history of Formula 1 had attempted to use steel in these conditions. This is an unprecedented solution, with no track record of success, without real benchmarking. And while that can be interpreted as a disruptive advantage, it also means that Ferrari is sailing in completely uncharted waters. There is no historical data to support this choice. There are no previous experiences to fall back on if something goes wrong. But the decision wasn't made just for engineering. It was an act of necessity. Following the departure of key technical figures such as Zimmerman and Schmidt to Audi, the new development team, led by Davide Mazzoni, needed to find a way to stand out, to leave their mark. And they found that way of technical differentiation in steel. They opted for an idea so radical that if it worked, it would make Ferrari an absolute pioneer of the new hybrid era. But if he failed, he would drag the team into the abyss that, to this day, steel remains an unfulfilled promise. Simulations show benefits, but physical tests still do not confirm its complete reliability. Thermal analyses suggest that the material's performance is excellent, but only under perfect conditions. On the track, with variables such as ambient heat, residue in the radiators, variability in the sustainable fuel mixture, or even dust on urban circuits, these margins become uncontrollable. The first and most obvious problem is weight. Steel, by nature, is much denser than aluminum. And although work has been done with lightweighting and precision machining technologies to compensate for this, the final result is irrefutable. Ferrari's new hybrid engine for 2026 weighs about 150 kilograms, at least 30 kilograms more than the previous unit. This figure, although it may seem marginal in other sports, in F1 it is catastrophic. This excess mass directly affects the center of gravity of the car. A heavier car requires more energy to accelerate, brake, and change direction. This not only makes it less agile in corners, but also directly affects the efficiency of the hybrid system. Under the new 2026 regulation, where 50% of the total power must come from the electrical system, each extra gram penalizes doubly. It forces more energy to be consumed in the electric motors, drains the batteries faster, and compromises the energy regeneration cycles. Electrical energy in F1 is no longer an add-on. It is a condition for competitiveness. If a car fails to maintain the balance between consumption and regeneration, it is doomed to be out of rhythm, unable to use all its power at key moments. For this reason, the most conservative engineers on the team have already started talking about a term that no one wants to hear in Maranello: structural inefficiency. Not due to lack of talent, but due to the choice of an architecture that simply does not fit the real requirements of the new technical regulations. But if the weight is the visible blow, the lack of reliability is the hidden dagger that can sink the entire season. The first alarms sounded on the test benches. Under extreme loads and full racing simulations, the engine showed worrying signs of thermal stress in secondary components. They were not catastrophic failures, but they were clear signs that durability was not guaranteed. In particular, concerns arose in the area of the MGUH and in the integration seals with the hybrid cooling system. In other words, the engine isn't breaking down, but it is on the brink. And this is where the most disturbing factor comes in. Ferrari has decided to go ahead with this power unit despite not having fully validated its long-term reliability, which means that the SF26 will hit the track with an architecture that has not yet been subjected to full racing conditions in a real environment. A very high-risk bet in a sport where abandonments not only mean lost points, but can condemn an entire competitive cycle if they occur at the wrong time. In this context, Ferrari's strategy has become a kind of technical roulette. They have opted for power and are leaving reliability for later, in the hope that time will work in their favor. But F1 history is clear. Teams that prioritize immediate performance over structural consistency often pay a high price. It is enough to remember what happened with Honda in its return to McLaren, or more recently with Alpine in its combustion experiments. Without reliability, power is irrelevant. The SF26 is not just a machine. It's a statement. It is proof that Ferrari is willing to do anything to return to the top. But it is also a brutal reminder of how fragile that ambition can be when it is based on a structure that has lost references, on a technical leadership that is still seeking to consolidate itself, and on a bet that, if it fails, there is no turning back. Subscribe to continue uploading more of that content. Now you really think about all this.